Welcome to a visual exploration of one of the most fundamental principles in economics, mathematics, and life itself, the difference between linear and nonlinear relationships, and specifically, the pervasive law of diminishing returns. We often assume that if a little of something is good, then a lot of it must be better. But as we will see, the universe rarely works in straight lines. Let's start with the ideal, the linear world. In a linear relationship, the output is directly proportional to the input. Imagine a factory where every worker added increases production by exactly the same amount. If one worker makes 10 chairs, 2 workers make 20, and 10 workers make 100. This is represented by a straight line, where the slope, the rate of change, remains constant no matter how much you scale. However, the real world is rarely a straight line. Most systems are nonlinear. This means the relationship between cause and effect is not constant. In a nonlinear system, doubling the input could result in quadrupling the output, exponential growth. Or, more commonly in physical systems, it could result in a much smaller increase than expected. This leads us to the heart of our topic. The law of diminishing returns, also known as the law of diminishing marginal productivity, states that as we increase one factor of production while keeping others constant, we eventually reach a point where each additional unit of input yields less and less additional output. It was famously observed by classical economists like David Ricardo and Anne Robert Jacques-Turgot in agricultural settings. To visualize this mathematically, we look at the slope of the curve. While a linear graph has a constant slope, a curve representing diminishing returns has a slope that decreases as we move along the x-axis. Using calculus, we can see that the first derivative, the rate of growth, is positive, but the second derivative is negative, meaning the growth itself is slowing down. Think about studying for an exam. During the first 2 hours, your focus is sharp, and you absorb a massive amount of information. This is the sweet spot. By the 5th hour, you're tired. You are still learning, but much more slowly. By the 10th hour, you might even experience negative returns where fatigue causes you to forget what you learned earlier. The marginal benefit of that 10th hour is nearly zero. In business and industry, this is often seen in the too many cooks in the kitchen phenomenon. If you have a small kitchen and keep adding chefs, eventually they start bumping into each other. They waste time waiting for the stove or the sink. Total production might still go up slightly, but the efficiency of each individual worker drops significantly because the fixed space, the kitchen, cannot support them. Even in the modern world of artificial intelligence and data science, we see this. Adding more data to train a model usually improves its accuracy. However, going from 1 million to 2 million data points might improve accuracy by 5%. Going from 100 million to 200 million might only improve it by 0.1%. The cost of computing power increases linearly or exponentially, while the marginal gain in intelligence shrinks. In conclusion, understanding diminishing returns is about finding the optimal point. It is the point where the cost of adding more input outweighs the value of the additional output. Whether in economics, fitness, or technology, the goal isn't to maximize input, but to optimize efficiency. Remember, more is not always better. Better is better. References: Gujarati D. Non, Basic Economics; Ricardo D., Principles of Political Economy and Taxation; Samuelson P., Economics.